camera app is going to work here. Cool. Those other apps. Good. All right. That's super fun. There we go. Okay. So we are still in the middle of solving equations. So this is topic 2-3. We're talking multi-step equations. This is really all about the distributive property. Yeah. So when solving multi-step equations, sometimes you distribute first and then combine like terms. So generally when you have parentheses, you want to distribute your terms. So distribute just means that you're taking the number outside of the parentheses and then you're multiplying it by the numbers inside the parentheses, right? This is a great technique to do pretty much all the time. There are a few instances when you don't want to do this first, and we'll do a couple of those here and in class definitely when we have like a practice day. But yeah, the idea here is you take that number outside, multiply it by the number inside. The numbers inside, you got to do both or all three, depending on how many numbers are inside the parentheses. Okay, so 7 times 5 is 35. 7 times 2x is 14x. And then at this point, now that you've kind of gotten rid of the parentheses by doing that, now you can combine like terms, right? You would take that 14x and that x plus, excuse me, just add them together, you get 15x, and then you solve it just like normal, right? So this is an example where you distribute first. This is an example where you combine like terms first. So you could add that 5x, that 9x to get to 14, and then multiply. I mean, you could distribute first if you wanted to and get to 40 and then 72, which is like 112, but that's what 8 times 14 is, the same thing. I mean, it's going to get you the same thing, but I don't know, distributing first or combining like terms first if you need to is probably a little bit easier. I don't know. 6 of one, half a dozen of the other. Okay. So for this first one, we're going to use the distributive property to solve a multi-step equation. So the teacher, who's like a math teacher, who's like just tracks how much he bike rides, wrote a total of 4x plus 3 miles on Monday through Wednesday. So he wrote x plus 7 miles on both Friday and Saturday. How far did he ride on Thursday? So the total number of miles he rode on Monday through Wednesday, this 4x plus 3, is the same as the total number of miles he rode on Thursday through Saturday. So since this group here, nope, dang it. Come on, we'll start getting it together. Just chill for a second. There we go. So the idea is that this group here, Monday, Tuesday, and Wednesday, right, is going to be the same as this group here combined, okay? So the idea here is we have this 4x plus 3, and it's equal to x from Thursday, and then 2 of these, which are the same, which we can just say 2 times x plus 7, okay? So that's the idea here, right, is we have this 4x plus 3, and it's equal to x plus 2 times x plus 7, all right? And now we want to kind of get rid of those parentheses first, so I'm just going to bring it down here. So 4x plus 3 equals x plus 2 times x plus 7. So we're going to distribute this 2, so we're going to multiply this 2 times that x and times that 7. So I'll just bring down everything I haven't changed. X plus 2x plus 14. Okay, so 2 times x is 2x, and then 2 times 7 is 14. You got to multiply the number outside the parentheses by every number inside the parentheses. Sorry, every term, because that's a variable, not a number. Okay, and now we combine like terms. I've got this x and 2x. I can combine that to 3x. So 4x plus 3 equals 3x plus 14. And now it's kind of just like a regular equation where we have variables on both sides. I'm going to bring the 3x over here first. I mean, you could do the 3 over here first if you wanted to. I just like to do my variables first. So yeah, since this is a positive 3x, you're going to subtract it. Those cancel. Now you're left with x plus 3 equals 14. Because 4 minus 3 is 1x or just x. Subtract 3. That's the opposite of being positive, right? That's subtraction is the opposite of addition. So to bring it across the equal sign, you have to do the opposite. So 14 minus 3 is 11 miles. So on Thursday, this cat, this rad math teacher that, I don't know, tracks his data like that, wrote 11 miles, and then you can figure out what he wrote on each other day, right? If x is 11, then he wrote 18 here, 18 here, and then here he wrote 40, well, like 11 times 4 is 44 plus 3, 47 miles over the course of these 3 days. So that's that. It's just another tool in your toolbox, like combining like terms and fraction busting. Is this distribution, right? Just simplifies things to make your equation easier. Sometimes you'll have a negative coefficient, right? So you'll have a negative number that's outside the parentheses. You do it the same way, right? You just multiply negative 5 by both of those terms. Negative 5 times x is negative 5x. Negative 5 times negative 2, since we're multiplying two negatives together, those are going to get you a positive number, so positive 10. And now you just solve normally, right? I'm going to take this 10 to the other side. We're at step 4, I think, on the steps for solving equations. Subtract here. Okay. We're at negative 5x equals negative 25 minus 10 isn't 15, it's negative 35. Remember, right, the shortcut is add them together and then make it negative at the end when you are subtracting, right? So a negative number minus another number. This negative 25 minus 10 is basically the same thing as this. Negative 25 plus a negative 10, right? That's the same exact thing. So that's where that adding them together and then making it negative comes from, right? We'll divide by a negative 5 here. And we end up with x equals, let's see, the negatives are going to cancel. And 35 divided by 5 is 7. So we get x equals 7. Just like that. Yeah. We have a negative coefficient out here. In fact, it's a negative 1. Right? Just remember, there's not another number out front. It's 1. So you take that negative and multiply it here. All that's going to happen is it's going to change the signs of these, right? So it's 3 minus x, because negative 1 times x just gives you a negative x, and then negative 1 times a negative 3 changes that to a positive, just like so. Now we will combine like terms. We have this 3 plus 3 over here. Since they're on the same side of the equal sign, you don't do any inverses, right? The only time you do inverses is when you cross that line, cross the equal sign line, okay? But since these are on the same side of the equal sign, we just add them together to get to 6. Subtract 6. And you're at negative x equals 19, right? And you can divide by negative 1 here on both sides. But the shortcut is you're just going to take that negative and transfer it to the other side. That's what that dividing by that negative 1 does. Like so, just transfer it over. I mean, if you want to see what that looks like, I suppose. Let's see, we have a negative 1 out here. You're going to divide by negative 1 on both sides. Those cancel, leaving you with a positive x. And then 19 divided by negative 1 just makes the 19 negative. So, just like so. We have fractions here. Oh, that's a cool box it just made right there. I mean, you could take that 1/4 and distribute it by both terms. Totally, like that is going to work. But then you have 1/4. Like it makes it a lot more complicated when you do that. Let me just show you what that looks like. Right? You get 1/4 x plus 3/4 equals 1/2 x plus 1. So it basically just gives you a lot more fractions. So what I prefer to do instead is to fraction bust this. We will take a number determined by the denominator and multiply it by both terms right here, and it'll get rid of our fractions. Now, one thing that's different about fraction busting when you have these parentheses is these parentheses basically act as like a shield or a force field. They protect what's inside the parentheses, so you don't need to multiply the number you're fraction busting by that x and by that 3. You only need to multiply it by the 1/4 and the half, right? So what that looks like is, and the number we're going to multiply by is 4, right? You multiply by 4 here, and 4 here. 4 times 1/4 is just 1, so we're left with x plus 3. And since it's 1 times x plus 3, you don't need the parentheses anymore. You can just get rid of it. And then this 4 times 1/2, half of 4 is 2. So it takes those parentheses away. And since the parentheses protected the inside, you don't need to multiply like that x and that 2 and that x and that 3 by that 4. You don't need to do that because the parentheses protect them. So now we'll distribute this 2 like so. You get to x plus 3 equals 2x plus 4. I'm going to just subtract over here, and I'll get 3 equals x plus 4. And I'll subtract 4 to the other side, and I get x equals -1 as our answer. Now, this is not the only way to do these types of problems, obviously, right? Right. You could solve it like this. Like you could do this, and then you convert that to 2/4, and then combine those together, subtract that 3/4 to get to 1/4, and then multiply by the reciprocal on that x. So there's definitely different ways to solve these problems. I would say that this is probably the easiest way to do it, the most efficient way. Another way to do this is you could multiply, well, it's the same thing, right? Multiply by this reciprocal, 4/1 on both sides to get rid of the fractions, which that is fraction busting effectively in this case. So yeah, I don't know. Whenever you see a fraction, just fraction bust it. I don't know. It's kind of a cheesy term, but it works. All right. Example number 4, we're going to do the same thing, right? Again, we could distribute that 1/6 and that 1/3 if we wanted to, but it is much easier to just multiply by the 6 right here, because that 6 is going to, 6 divided by 6 is 1 is a whole number, and then 6 divided by 3 is 2, that's a whole number. So right, that's what we do. You could also multiply by 18 by multiplying the denominators, and that would result in bigger numbers, but it would give you the same answer, right? So if you're struggling to find the number you multiply by, to get rid of multiple fractions, just multiply by the denominators, right? 6 times 3 gives you 18, right? It'll make bigger numbers, but I mean, not a big deal, right? Now, 1/6 of 6 is 1, or 6 divided by 6 is 1. So again, since it's 1 on the outside, you can just get rid of the parentheses. And 6 times 1/3 is 2, or 6 divided by 3. 2 times x plus 2. Well, that looks much easier than those fractions. Now I distribute. I end up with a minus x minus 3 equals 2x. 2 times x is 2x. And then 2 times 2 is 4. And I'm going to take this x to the 2x again. The reason I'm doing that, guys, is because it gets rid of the negative on the variable. And that's kind of just situational. Like you could very easily take that 2x to the other side and get a negative x, add that 3, but then you have to divide by that -1. So I don't know. Again, multiple ways you can solve these equations. Subtract 4, bring it over, and then -3 minus 4. Remember that -3 minus 4 is the same thing as -3 plus -4. Okay, add them together, make them negative. You get x equals -7. And that's that. Did I put the key concept 2 different places here? I did. Really good editing there. Wishart. Awesome. Look at that. It's the same thing, right? You distribute. Well, sometimes you combine like terms before distributing. Yeah. Let's see. Where is my note? I'm going to fold that in half. Let me go find my notebook real quick. All right. This is going to go on page, I don't know, 21 maybe? Yeah. Okay. So it's going to go 2-3. Page, double check, 21, yep. 21, solve multi-step equations. Just like that. You'll glue it in, obviously. I'll glue it in a minute. You don't have to see me doing that. And then in your notebook, this is going to be 2-3. Solve multi-step equations. There it goes on page 21. Yeah, there you go, guys.